So the first two videos in this series about average value of a function are just going to focus on actually finding the average value of a function. But before I dive into that, I really want to take a brief moment to mention that we already know how to find averages. For instance, suppose that you know on quizzes you got scores of 10, 18, and 20. What would your average score be? Okay, well, we know that we just add together the scores that we received and divide by the total number of scores that there were. This gives me 48 divided by 3, which gets me 16. Again, I didn't need to include this in the video, but I just wanted to point out to you the concept of average is very simple. You add together the things that you have, you divide by how many of them there were, and the answer is what your average was on that thing. And that's really going to be the same thing that I'm going to do here. So really, before I do anything else, I'm just going to tell you effectively what the formula is for finding the average value of a function. So here we go. The average value of the function on the interval is given by 1 over b minus a times the integral from a to b of f of x dx. And that's it. I mean, that in some sense is the formula that governs everything that we're going to do in the lessons and the videos that we're covering today. I want to make a connection back to the way that I was talking about averages before, which is to say that I suppose there's another way to write this that may help you to see it. Technically, we could write this as the integral from a to b of f of x dx divided by b minus a. Note that those two things are effectively saying the same thing. And the reason that I point that out is remember what you already know about averages. What you already know about doing an average is that the way that we do it is by adding up a whole bunch of things and then dividing by how many there were. And that's effectively what this formula is doing. You may remember from one of my first videos about anti-differentiation, particularly with finding areas, is that at its core, and you'll hear me say this throughout the entire year, at its core, what an integral really does is it adds things up. What this thing is doing is it's adding up all of the values of f of x between a and b. Now, it's multiplying in some width also, but what's happening is it's adding up all of those rectangles. And then here, I'm just dividing by how long is the interval that I'm going to add up rectangles for. So the point I really want to get across is the average that we all know and love from before, that you just, add things up, divide by the number of terms, is effectively the same thing that's being done with the average value of a function. With that said, I'm going to dive right into an example of this thing. So we want to find the average value of this function 4 plus 2x minus x squared on the interval from 1 to 4. So based on the formula that we just got up above, we need to do 1 over b minus a times the integral from a to b of f of x dx. So really this is just a matter of plug stuff in. This is 1 over 4 minus 1 times the integral from 1 to 4 of 4 plus 2x minus x squared dx. So this is 1/3 in the front. We can actually take this antiderivative. It'll be 4x plus x squared minus 1/3 x cubed. And that will all be evaluated between 1 and 4. So, as you recall from our previous lessons, we evaluate this by plugging in the 4 and plugging in the 1 and subtracting. So I will have 1/3 of 4 times 4 plus 4 squared minus 1/3 times 4 cubed minus 1/3, and this time I plug in 1. So that'll be 4 plus 1 minus 1/3. I'm kind of just mentally doing that rather than writing them all out. This now gives me 1/3, 16 plus 16 minus 64/3 minus 1/3. This is going to be 5 minus 1/3. This gives me 1/3 of, let's see here, combining these two things together is going to give me 32, but I'm going to want a common denominator with this, so I'm going to make that 96/3 minus 64/3. minus 1/3. And again, I need a common denominator here, so this will be 15/3. 15/3 minus 1/3. And we're getting there. I'm going to do the subtraction and multiply by 1/3 at the same time. The 96/3 minus 64/3 should be 32/3. So when I multiply by the other 1/3, I'll get 32/9. Minus over here, I'll have 14/3 times 1/3 will give me 14/9. And subtracting those two things from one another will give me 18/9. Which gives me the miraculously awesome answer of 2. What a nice, pretty looking answer. Okay. Now, I do want to take a minute to sort of cover the so what component. So you're like, all right, we started this question up here that was asking me to find, the average value of this function. And it turns out that average value is 2. So what does that mean? Like, what significance does that have? And I think I can show you a little bit of that significance by looking at a graph. So I'm going to bring up a graph of the function. All right, so here it is. Here's a graph of this function 4 plus 2x minus x squared. And what this question had asked us to do is it asked us to find the average value between 1 and 4. So what I sort of want you to sort of think about and imagine is, what is the average height of this function? I mean, like right here, the height of the function is, 4.5 or so. Over here, the height of the function is 4. Here it's, like 3. Here it's 2. Here the height of the function is 1. Here the height is 0. Here the height is -1, -2, -4. If I were to sort of add up infinitely many of these heights, lots and lots and lots and lots and lots of those heights, and sort of average them all together, what would the average height be? And what my problem seemed to be indicating to me is that average height would be 2. Like, in some sense, here's the height of 2. And the problem is saying, on average, the height of this function is 2. And that should seem kind of realistic. We've got a number of values over here that are, in the 4 and 5 range. You've got some here that are coming down below that, and we have to average out with some negatives as well. I hope it seems reasonable to you guys that this average value is 2. So that was the end of the first example. I do have one other example, sort of a stranger one, so we'll go through that one, and hopefully I can make it pretty quick. Let's take a look. All right, so for this problem, I want us to find the value of k greater than 1 such that the average value of g of x, which is 2x minus 1 on the interval from 1 to k, is 6. And I can't stress enough how important it is that we learn how to read and do problems. So suppose that you're looking at this problem and you have no idea what to do. Start to dissect it. The first thing you have to ask yourself is, what do you have to do? This question asks you to find the value of k. So in some sense, at the end of the problem, like in the bottom right corner of all of your work, you're going to have k equal something. Like, we need to find out what k is. Now, what other information are you given? You're told that the average value of this function needs to be 6. In other words, we're going to sort of start this problem by saying, okay, I need to find the average value, and it needs to be 6, right? So then we just have to address, well, so how do you find the average value of a function? Well, that's the thing that we've been learning in this section, right? We found that in order to find the average value, I'm supposed to do 1 over, now it's supposed to be b minus a. My values of b and a are k and 1. It's okay, I'll do 1 over k minus 1 times the integral from 1 to k of my function 2x minus 1 dx. And I'm saying that this needs to be equal to 6. Now, on the one hand, this problem looks daunting because you've got letters all over the place. But in some sense, don't be scared. We want to find k. Like, it's important that k sticks around in this problem because that's what I need to solve for. Effectively, x is what I need to get rid of. So I'm just going to start working through this. 1 over k minus 1 is a constant, so I'm going to leave it there. The next thing I'm going to do is I'm going to evaluate this integral. I know there's letters all over the place, but we can deal with it. That integral is x squared minus x, and I'll be evaluating that from 1 up to k. And this, in the end, needs to be equal to 6. right? So, all right, now I have 1 over k minus 1 times, now again, I'm going to plug in the top number minus plug in the bottom number. So this will be k squared minus k, that's the top, minus plugging in the bottom is 1 minus 1. All right, so this ends up just dropping out. And it looks like what I end up with is 1 over k minus 1 times k squared minus k has to equal 6. And again, on the one hand, like this is looking not so great. I don't know that I want to deal with this. On the other hand, maybe it's not that bad. What we can do is we can multiply the k minus 1 over to the other side, so that we end up with k squared minus k equals 6k minus 6. And now this is just a quadratic. I can just move things around. If I move both of these terms over to the other side, I'll end up with k squared minus 7k plus 6 equals 0. And we can factor that. This factors as k minus 6, k minus 1 equals 0. So setting each of those equal to 0, we get k is 6 or k is 1. I'm not going to scroll back up to it, but in the original statement of the problem, it said that k had to be greater than 1. So it turns out the value of k that they were looking for was 6. Hope that made sense. I'm going to stop this video now and move on to the next one. I will see you there.